Hello and welcome to another GCSE Computer Science video on data representation with me, Mr Goff from mrgoff.com. The focus of today's video will be character encoding. To store text, computers refer to character sets. A character set is the complete list of characters a computer can represent and the respective binary codes for each character. There are two key character sets you need to be aware of: ASCII and Unicode. ASCII stands for the American Standard Code for Information Interchange. It was initially 7 bits, meaning it could do 128 characters, but was expanded to 8 bits so it could do 256 characters later on. You should also be aware that in ASCII, similar characters are grouped and run in sequence. For instance, uppercase letters start at capital A at 65, and run through to Z at 90. Lowercase letters start at lowercase a at 97 and run through to Z at 122. Digits start at 0, which is 48, and run through to 9, which is 57. If you compare whether one letter is greater than or less than another letter, it will actually compare their ASCII values to work out whether or not that is true or false. Unicode is another type of character set. It can use either 8, 16, or even 32 bits. Its codes are the same as ASCII up to 127. The big advantage of Unicode is that it can represent all characters in all languages from all over the world. As well as other languages, Unicode has allowed us to encode all the emojis that have become so popular. You need to be able to convert between characters and character codes. You should be able to use an ASCII table to do this. The pseudocode methods, code to char and char to code, can each be passed either a character or a value and convert from the ASCII value to the character or the character to the ASCII value. You're likely to be asked a question something like this example here, which also relies on your knowledge that characters run in sequence within the ASCII language. So if we said code to char, char to code A plus 3, well, char to code A would return as 65. We would then add 3 to it, that would be 68. We know that 65 is a capital A, 66 is B, 67 is C, 68 is D. So we've got a capital D is what that would equate to. That brings us to the end of this video on character encoding. I've been Mr Goff for mrgoff.com. I hope you'll join me again soon for another data representation video. Our next video will be focused on representing images. Bye for now.